So in this video, we're going to look at functions of two variables. So we can define a function in terms of both x and y. So we can define a function z or a function f in terms of two variables, x and y. And so f is going to depend both on the value of x and y. So x and y are the independent variables, and then f or z is that dependent variable. And so if we look at this function f of xy equals x squared minus 2xy minus y squared, this function f, which again, sometimes they say it's z equals that, is going to depend on both the value of x and y. And if we were to graph these functions or graph these points, we are going to have 3 points in the end. And so we graph it where we have an x-axis, a y-axis, and z-axis. It looks like this. We're not going to worry about graphing those points. It's going to be on the scope of this class. But if you ever take a calculus 3, they talk more about graphing the points and what the curves look like. So in this case, we're just going to evaluate our function at different values of x and y. So when it says f of 5, -2, my first coordinate is x. That's how they defined it. And my second coordinate is y. So x is 5 and y is -2. And we're just going to substitute that into our function and evaluate it to find the f value or that z value at this point. So we have 5 squared minus 2 times 5 times -2 minus -2 squared. And then we just simplify. So we have 25 minus -2 times 5 is -10 times -2 is a positive 20 minus -2 squared is 4. So we have 45 minus 4 and we get 41. So again, f of 5 -2 is 41, or again, sometimes they say z equals 41. And then if we talked about what the actual point was, the point would be 5 -2 41. But again, most of the time we're just going to write it as f of xy equals whatever value we get. Now, there are some business applications for this. Again, mostly kind of revenue, cost, and profit. So often revenue, cost, or profit are not just dependent on one good. They can be dependent on 2 goods or even more than that when we're talking about a company's revenue or profit. In this class, we're just going to stick with at most 2 types of goods, but just know in the real life, a lot of times companies' demand and profit functions are much more complex than what we're going to do. So in this case, we're going to have 2 goods, x and y. X is the number of items of good 1 or whatever they define it to be, and y is the number of items of good 2. And if we're talking about the revenue of 2 functions, we say the revenue of xy is the revenue for producing x and y goods. Now, if we think about revenue, when we talked about it with just a function of one variable, we always took the number of items times the demand function. And again, the demand function gives us that price per item in order to get our revenue. And so the revenue of 2 functions is the same idea. So we're going to have 2 demand functions when we have a revenue in 2 variables. We often define them as P and Q. So P is the demand equation for good 1, Q is the demand equation for good 2. So then to find the revenue, if you think about it, what we're going to do is we're going to take the demand equation for good 1, or that price that we get for good 1, and we are going to multiply it by the number of items that we sell for good 1, and that would give me the revenue for good 1. And then to get the revenue for good 2, we would take the demand equation for good 2, that price, and multiply it by the number of items of good 2. And then we are going to add those 2 together because our revenue is based on the revenue for both of those goods to get the revenue of xy. So the revenue for xy is the formula of x times p plus y times q. Okay? And so the main thing is just make sure you're multiplying the number of items for the same types of goods. So good 1 should go with the demand equation for good 1, and good 2, the number of items should go with the demand equation for good 2. So we're going to look at an example from the packet. So a company has determined that the demand equation for 2 types of products are given by, and the formatting on this one is weird, this P equation and this Q equation. And the weekly cost function is given by this cost function. Now P is that demand equation, which is the price of their standard product, and Q is the price of their luxury product. So instead of saying good 1 and good 2, they're talking about standard and luxury products. X is the weekly demand for their standard product, and Y is the weekly demand for their luxury product. Again, that's like the number of items that they're selling. So we want to find the weekly revenue function R of XY and then evaluate it at R of 2010. So again, this is my X and this is my Y. I first have to find that equation. So again, that equation is going to be, so we have standard product. So we're going to take our standard product, which is X, is the weekly demand for the standard product. And we're going to multiply it by that demand equation for X, which is P. And then we're going to add the luxury product. So Y is the weekly demand for the luxury product, and we're going to multiply by the demand function Q. And then I'm going to substitute these functions in. So P is 220 minus 6x plus Y, and Q is that 300 plus 3x minus 10y. And then we want to distribute and simplify this a little bit to get the equation. So we get 220x minus 6x squared plus xy. I'm distributing my x. And then I have plus 300y plus 3xy minus 10y squared. And then if there's any like terms, we want to combine them. So we have r of xy equals, so I have 220x, that's not a like term, minus 6x squared, but I have an xy and a 3xy, so plus 4xy, and then plus 300y minus 10y squared. Okay, so this is my revenue function. Then I want to evaluate that function at 2010. So I'm going to plug 20 in for all my x's and 10 in for all my y's. Okay, and just make sure you're plugging it in correctly, like in the right spot. So x is 20, x is 20. Here I have an x and a y, and then I have y10, y10. And then we can just evaluate this in our calculator. Okay, and so I got the revenue is 12,000. Okay, again, when we're having x as being 20 and y is 10. Okay, so that's my revenue. Then it says the weekly, find the weekly profit, P of XY, and then find P of 2010. Okay. Right, so profit is the same as idea as what we did for when it's function of one variable. To get the profit, we always take the revenue and then we subtract out the cost. So we had to find our revenue function, which we did. So our revenue function is this 220x minus 6x squared plus 4xy plus 300y minus 10y squared. And then I'm going to subtract my cost function, which is here. So 40x plus 80y plus 1,000. And then if we can, we're going to simplify. So I'm going to distribute that negative. And then if there's any like terms, we are going to combine them. So I have a 220x minus 40y, or sorry, minus 40x. So I have a 180x. I only have one 1x squared term, one xy term, and then I have a 300 minus 80. Okay, so I get 220y, and then minus 10y squared, and then minus 1,000. And then they asked me to find the profit when x is 20 and y is 10. And so we're going to just substitute that in. So anywhere I see an x, I'm going to plug in 20. And anywhere I see a y, I'm going to plug in 10. Okay, and then we're just going to type this all in and we get 2,200. So this would be our profit for selling 20 standard items and 10 luxury items. So that's an introduction to functions of two variables.